just in book.
PPT, please.
Back.
Is this me? Just me. Cool, thank you so much. Perfect. Thank you so much, Charles, to present. So many reasons this really didn't happen, or nearly didn't happen, and it's happened, and I'm really pleased to be here. And also, apologies for my voice. It will hold up for 10 minutes. It's on the kind of rebuild after a bit of boiliness. So I'm going to be showing you a piece of kind of ad hoc work that we've done outside of most projects, where we've been working on how to actually get really detailed discovery metadata from DAX to Ocean InfoHub, whilst also working with our existing partners to actually have the most efficient flows of information possible. And it's one of the last pieces of work that I did before I kind of shifted roles, but it kind of brought in one of the key lessons that I've learned recently, which is the power of the team. And in order to make this work happen, it's actually taken an awesome team of people from across 4 different groups, actually, if you look at the detail here, to actually get the solution that will actually get us to a very efficient way of actually working that actually works for everybody. So we've had kind of people from BODC, Colm's actually represented Medin here, which is really cool. And then we've had people from Maris and also people from Ocean InfoHub all contributing to this work. And yeah, a super team to actually do this. So I'm going to start by actually looking at kind of introduce what we've done, show a bit of the results, and then show kind of how that kind of works and where we're going in the future. And I think the first thing to show is kind of Ocean InfoHub. I'm conscious the talks are slightly out of sequence this morning, so I'm going to give a very brief introduction to Ocean InfoHub, but not steal the thunder from the person who's talking about Ocean InfoHub after me. But to say that Ocean InfoHub is actually kind of a relatively new player to the scene. It's part of the UN Decade. It's become one of those portals that we need to get metadata to, so it can serve specific communities and actually get information out there to the oceanographic community. And reputationally, it's become a key portal to get information to, because it's one of the places you actually want to see your information and see your metadata. And then underneath that Ocean InfoHub, which is the portal that you can see on screen, you've got ODIS, which is the Ocean Data Interoperability System, and that's kind of a mechanism to actually get the data to there and the bit that sits underneath. They've got lots of really nice linked open data, and then that gets translated into this portal here. They've got a pool of documentation, which actually really, if you need to connect, they've actually got a kind of a cookbook, and if you learn new things, they're really quite keen that you contribute those to the cookbook, so it actually becomes a piece of community documentation that's all managed through GitHub. And this link has become a key one that we've needed to develop internationally. There's an enabling technology behind this, so most people recognize it, schema.org. It's that thing you use to get your metadata up to Google Dataset Search. And that's the key language that's used to actually represent all this metadata. But the piece of work that kind of kicked things off and got me really thinking about this at the beginning was I was part of, or lucky enough to be part of, a group called the Marine Ecological Time Series Research Coordination Network. It's an NSF-funded research coordination network in the US, and it brings together the Hawaii Ocean Time Series, Bermuda Atlantic Time Series, California Kalkofe Time Series. So all those big key seminal US ocean time series actually brings those together to make their data fair. And we had this most wonderful workshop in Boston, where it's like going in Wayne Manor. And we were waited on by staff, and we got fed, and we had 3 days to generate schema.org templates to represent some of their critical leading ocean time series. And we actually end up with these very detailed schema.org templates that add the most beautiful contextual metadata that any researcher could use to actually use that data. And that has become kind of the ambition of getting that data up to Ocean InfoHub. So there's a key challenge in all of this. It's not just a case of BODC can just produce those templates and share it. BODC are a partner with and a key node in groups like CDataNet and groups like Medin. So how do we get, as a community, get our metadata to Ocean InfoHub in the most efficient way, whilst also allowing that beautiful additional contextual metadata that we started scoping in the METS RCN work there too. And that's kind of the key things that I want to show you. So I've kind of captured that in two sentences to kind of give us a bit of focus. So that's like, how do we efficiently get the metadata served to Ocean InfoHub via the existing partnerships in the most efficient way? But then how do we also enable that kind of leading edge, cutting edge, new contextual metadata that the researchers really want for this key time series? And that kind of, that was the basis for the work. So we went off, we used a bit of Envy Fair money for this bit. We ran a couple of sprints where we did some design work. And I'm going to show you the results of those design work, and then I'll kind of show you the end results. So this picture here is actually from that design work. And this shows you how we actually took the different types of metadata and actually aligned them to the schema.org templates. So up here you've got the ELET extended line station, which is the ELET line is a line that the UK do off the UK, and it's a series of CTDs that we do every year. Then you've actually got the research crews associated with, and then the CTD event, and then effectively the data set that sits underneath. And up here you've actually got the fixed station, i.e. the station we do every year in that series. And you can see how we've actually mapped that to the event and sub-event categories within the schema.org template system. And then as you're going down the page here, we've got a separate one for sea level, where we've got the data set at the bottom, and then we've got the tide gauge deployment, and then effectively you can see, so this actually shows us how we did that modelling to get to translate what we've got at the moment across those schema.org templates. Just to say that Alexandra are both here, and if you want to look at the detail over a cup of tea, we'll be probably with our posters tonight, but we're also about all week. And then what we ended up with was this kind of hybrid model. So it's a combination of kind of the C DataNet nodes that we have. And I'm really glad that Dick presented this morning and you got to see all the acronyms there, because there's quite a lot of acronyms in these slides. And then the elements that BODC serve. So at the bottom you've got Ocean InfoHub and Odis down here. And you can see the green blobs are effectively what we're serving at the BODC level. And the green blobs on this side are what are being served at the C DataNet level. And I know that C DataNet actually developed and exposed more of their data in schema.org to actually make this possible as well, which is fabulous. And between this and having this kind of hybrid model, we've actually managed to actually generate JSON LD templates based on schema.org that have all those contextual links, have some of that additional beautiful contextual metadata the researchers want, and actually get that up to Ocean InfoHub. And then we broker it. So effectively, what we did is we created a sitemap on our website with additional metadata at BODC level, and this gets harvested by Odis. And this is just an example of that JSON LD, but I'm not going to dwell on that for this short presentation. So I'm going to show you kind of what this has led to and kind of the results. So this is the model we ended up at. So effectively, you can see we've got 2 additional pink arrows. We have kind of the core metadata being served by C DataNet and Medin to Ocean InfoHub. And then we've got that kind of that extra kind of research level stuff, the new elements that are not possible with the infrastructure being served separately. And as time evolves and C DataNet and Medin become more capable, that kind of pink arrow at the bottom will get smaller, and then new requirements come along, and then we can develop those, and that pink arrow will get bigger again. So effectively, it'll be a transfer of capability up from BODC into C DataNet and Medin as we develop the new abilities to do things. And it means we can have that constant flux of the core data going through our partners and the research data coming through us. This is a visual representation of one of those JSON LD documents, which Alexandra produced for us to show that yes, that's possible. And this slide here is actually by Pierluigi, and he let me borrow this. As this is one of the slides he produced for one of his keynotes, who shows that this is the data that you can currently see in Ocean InfoHub. And then people like BODC come along and C DataNet come along, and you get maps like this, and all of a sudden, all of the boundaries disappear because there's so much metadata and so many more stations that appear. So once all of these data go live, it gives much more information to Ocean InfoHub, and it gives a much more complete set of records. And I'm quite proud of the fact. Thank you. I'm quite proud of the fact that we actually managed to destroy the coastlines on this. It wasn't what we planned to do, but that was the result. So last slide. So as part of this work, we've actually developed a hybrid model. It allows us to serve all of our core metadata via our partnerships and existing relationships. But then we've also got the means to develop new capabilities, which we can then transfer into our partners as we work with them. At the moment, in terms of the stuff that's live on the website, we've got the PAP site data. Serving the 400,000 records, actually, we discovered a load issue, and we're currently working through that. So you'll see that kind of blob on the maps once we figure out the load issue. But at the moment, we're just looking at key sites like PAP. And then it means what we can do in future work is when you get groups like carbon community come along, or chemistry communities come along, where we need to get the additional metadata through, we can actually do that in a relatively efficient way, and it means it shapes really well for the future. And thank you.
Thank you. Thank you very much for the presentation. Perfect in time. Questions? No? No. Okay.
Oh, disappointed. Yay.
So thank you for your talk. I have just one simple question. So, in one of your slides, you used dashed on plain lanes, and I didn't understand why. In one of your schemes.
Let's have a look. Tell me when to stop. Okay. Which one?
Well, I mean, you've some red lines, it's okay, but when you use blue lines versus purple lines, you also add some additional information because it's dash lines.
So dash lines is where the capability is limited, and it's current research. The blue lines is where we're making those linkages. The key thing about that big JSON-LD template is we're actually leveraging all the existing metadata. So we're leveraging the EDIOS records, we're leveraging the EDMED records, and we're actually building that map, that linked data graph, in the JSON-LD template. And the dash line, I think, is something we can't do yet. The red stuff is something we definitely can't do. But this is still not quite a complete project and still not quite a complete piece of work. But it's a huge step forward in terms of what we can do.
Other questions? Other?
And there's one at the back as well.
Thank you. Hi, Justin. I'm afraid I'm going to ask nerdy detail questions.
Sure.
I'm seeing a lot, I think the slide before this, a lot of subject of and about, so very generic semantics, meaning a lot of queries will need to additionally narrow down to the type, I guess. Or
so the very genericness comes from the very genericness of schema.org. It was originally created for things like media and film. Yeah. So you'll see that within the Ocean domain, what we've taken is we've taken a lot of terms very much used for things like describing films and songs and video, and then adapted those for Ocean data. And that's the key thing in this is the way that has been implemented is described in the Ocean InfoHub documentation manual, where they've actually given effectively a precise description of how the Ocean concepts actually map to each of those terms and give you that meaning.
Yeah, well, I was just questioning, you haven't found out this being limiting, that you always have to know?
It's even more freeing, and if you speak to Alexandra, it's too freeing. So one of the challenges in schema.org is that it's a very generic set of standards, a very generic framework that you can use, and it can, in its own right, also create ambiguity. But at the same time, it's also used widely across the web and by many people globally. So there's this whole balance between having a super generic framework and having something lots of people use. And the schema.org is very much a compromise. And if you look at some of the other work we're doing, you will have things like very precise semantics underneath, and then schema.org representations on top of that, because it allows you to have those super precise semantics with just the schema.org being another representation. But yeah, it's an imperfect solution, but it's a solution that the world uses. So there's a big compromise in using this